Can you guys hear me? Hello, can you guys hear me? Can you guys hear me? Oh, hello. Okay. I can't leave you guys hanging. That is the fear. Okay. Some of you have exam very close, and if there's nothing we can't, we just have to find a way. We just have to find a way. Okay. I know I'm really tired. I know I'm really tired, but I have to just come here, right? I have to. You saddle me with the responsibility to make sure like you pass your exams, and as such, I have to deliver on my promises because my name is the brand, and that is why I have to do this, even though if I'm not convenient. So to just be wise of you guys to make sure you take advantage of all these things I'm doing and utilize it to your own utmost advantage to make sure you do well in your exam. And that is the only way you will compensate me for all my effort. Okay. So yeah, good afternoon once again. I don't know. Hopefully I'll be able to take chemistry tonight. Like hopefully. But if I'm not, I'll just have to shoot it and do it together. But God will strengthen me. I'll be able to. Don't worry. Oh, God, strength help me. So let's go now. Now, we have 4 topics. So how are you? I'm not fine now. You know I'm not fine, but I'm so happy that I'm helping you guys. That's my major joy. Okay? I'm not fine, but if you are fine, if I'm helping you understand, if I'm helping you to understand your stuff, that's my joy. Okay? So that is my joy. Yeah, God help you. So amen. God will help you guys too. Okay, so we have 1, 2, 3, 4 topics to treat. Now I purposely move it. Is sorry, is around. Oh, don't worry. Let me just teach you. I don't know what to do. Don't worry. I don't. I think it's net. So I move it from here. It will come to this place. It will come here. Hey, what is happening? Should I just teach you? What's just tell me that I'll just teach you. Tell me that I'll just teach you. I don't know. Just tell me I'll teach you. I don't know what to do. I'm tired, but I'll just teach you. Time has gone already, sir. It's just 1 hour that is left. Let me just teach you, don't worry. So, yes, he has done a video, exactly. He has done a video. Definitely, he has done a video. Hey, don't worry. Let me just teach you, don't worry. He has done a video. That's why the problem, like, he has done 45-minute video on these topics. On it. He has done it. He has done this. He has done this. Thank you for those that care about me, right? I mean, life. His teacher is life. Just tell him that, it's just 1 hour class. Don't worry. This class will end by, it will end. Let me just teach you. We have not uploaded it. So now we'll start with elasticity. Elasticity, okay. We'll start with elasticity. Now, elasticity is, just like I used to explain this thing. The way I used to explain it is, just tell him, can someone message him to like stop? I will just teach you, don't worry. He has made a video, so there's no pressure. Now look at this thing. This is an elastic material. So when you say something is elastic, that means if you stretch this body, it should regain its position back. So elasticity is the ability. Elasticity is the ability of an elastic material to return back to its original shape after a force is being removed, right? Now, just like I just explained, look at this. You can stretch it. This is an elastic material. You can see when I stretch it, it returns. 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 Can you see? But if I stretch it so much, now don't forget I'm using force. Have you guys messaged him that you should stop teaching? Just message him that don't worry. Just send him in the DM that Dr. D has continued the class. Don't worry. I will just take you guys. He has recorded a video, so this one plus that one will make sense to you guys. So look at it. That means if this stuff stretch, right, at some point, if I keep applying the force, you realize that this stuff will break if it's so much. That's what they will tell you, that this guy has lost his elasticity because it has reached a breaking point. So what leads to this extension of this material is that there is a force, right? There is a force. So this is an applied force, which is directly proportional to the extension. That means this stuff will not extend unless there's an applied force. It will be here. When I apply a force, it will extend. So when this force that I apply is more than this particular, the elastic limit of this thing, it will break. That's why they say that the elastic material has reached the breaking point. That's why they say the elastic material has reached what? The breaking point. So what do you need to know is that, can you guys hear me? Can you guys hear me? Can you guys hear me, please? I'm hearing network on me. Okay, good. That means this is network. So now that means if you know this, that means who will undergo elasticity? Elastic materials will undergo what? Elastic materials will undergo elasticity. But something that you should note is that, just like I've explained with this my bead, is that the force that you applied is directly proportional to the extension. And that's this statement you are saying is given by what we call Hooke's law. Which states that the force, he said, provided the elastic limits. That's what we now state Hooke's law. He said that, I don't know if this, provided that the elastic limit of an elastic material, is not exceeded. It's important that you don't exceed it, because if you exceed it, you cannot talk about Hooke's law. Provided that the elastic limit of elastic material is that the force that you apply, the force, my camera is blurry again. Can you guys see it now? How is it blurry? Let me try to clean. Can you guys see it? Let me see. Can you guys see it well? Maybe it's your network. Is not exceeded. The force applied is directly proportional to the extension. So if I want to do it mathematically, it's just saying that force is directly proportional to what? Extension. Force is directly proportional to what? Extension. Now, if I now make this thing to be mathematical, I will say F is equal to, because anytime you change a proportionality sign to an equal to, there must be a proportionality constant K. Then this extension is what? Is E. This extension is E. So that's why you see that I can say K equals to no, not here, please don't stress me, please, I beg you, please don't do that. Just, you can screenshot, you don't have to write, please. So I beg you guys, I'm trying to just help and find a way to, please just don't stress, okay? Let's just keep the flow like that. It will be recorded, so I just have to do that because I've not gone far. If I've gone far, I won't go back. So now K is what? If I divide F equals to KE, so if I divide both sides by E, so you now see F all over what? All over E. So this thing that you are seeing is what some people, they call it force constant. They call it force constant. Sometimes they call it spring constant, depending. Okay. Now, what do you observe? That the unit of F is what? Is Newton. While the unit of E is what? Is meter. So that means the unit of K is Newton per meter. Abi? Is what? Newton per meter. So that is what they say here. Now, this is mathematical expression, right? Now, if I want to go for graphical representation, this one, you must know this one. Now, that means force extension in meter, force in Newton. That means, we said that force is directly proportional to extension, abi? That means the higher the force, the higher the extension. Just like you can see, when I was extending this guy, look at the force I applied. I increased the force. I increased the force. I increased the force. I increased the force. But if I increase the force beyond this stuff will cut. Now, that is what they call breaking point. Like, look at it. You were increasing it. If you realize that if I increase beyond this is the limit. This is the limit, abi? This is the limit of this thing. So if I increase beyond this, if I just make sure that it's beyond this, it will cut. So that point of breaking is what they call breaking point. So that means at first, because when this one increase, this one increase. When this one increase, this one increase. When this one increase, this one increase. When this one increase, this one increase, abi? When this one increase, this one increase. When it lost, yes, it will break. So that means at some point it will go like this, right? Then it will not get to a point, right? So this point is the elastic limit, abi? Then this point is the what? Is the breaking point. It has broken here because it has lost its elasticity at this point. It cannot return back to its position. So this point you are seeing here is the elastic limit. Then this point is this breaking point, okay? So these are points. So this is the proportionality limit. This one is proportionality limit. Proportionality limit, okay? Now, this one is the point before it breaks. This is the point where they are still proportional. Force is directly proportional to extension, directly, until this proportionality limit. Then from here, it has reached what? Yes, yield point is, you cannot even regain. Yield point, you have already yielded. So you cannot even go back to anything again, like you have finished. Do you get that? You have finished already. Do you guys get that? So that is yield point, that is elastic, that's elasticity. Do you get that? I'm looking at the comment section. After breaking point. Yes, it's after breaking point. I said yield point is that point after breaking point. Like when you cannot, like you cannot go back. What which side don't you get there? Which side? Which side oh? So is the yield point same as, no, they are not the same thing, oh, but they almost like happen. You know that breaking point, exactly. Plastic, you have plasticized the whole thing. Like you don't what's it called? Look at it. This is the elastic limit, this proportionality limit. Then you have reached yield point here, then the breaking point here. So here this stuff has turned to plastic. Then eventually it will just break. Do you get what are those squares? Squares, this one is not square now. I'm just showing as they increase, as the force increase, extension increase, force increase, extension. So now elasticity, we are teaching elasticity. So proportionality limit, elastic limit, yield point, then breaking point. Are we good now? Yes, yes. Before breaking, exactly. Yeah, yeah, yeah. So good. Let's continue. Okay, we'll come back to watch it if you don't get it. Now, another thing, that means you already know that F equals to KE, Abi? Everybody knows this. Yes, yes, yes. Now, look at it. F equals to, but you must know what we call the work done. The work done. And which is the what? The area. The area on the graph. The area on the graph. Now, you must know that, I don't want to prove all these things, but you must just know that F, half FE, that is work done. Half FE. So half FE, okay? Half FE. Half FE. So now, this is the work done. This is the work done. Now, don't also forget that F itself is what? From here, KE. So if I can replace this F with KE, that's why you see that work done is half KE. You know, this is force, Abi. Then I will still have E. So they will now say half KE squared. That is work done. Elasticity, oh. Half KE squared, okay? Half KE squared. So W equals to what? Half KE squared, or W work done equals to half FE. So it's either of the two, depending on how the question is framed. So that is that. Then the last one on this is Young modulus. Young modulus. Young modulus. So that's why I said we'll not waste time on this. Young modulus. Who can tell me the formula of Young modulus? But before you know Young modulus, you must know two things. Strain and what? What are the two things you must know before you can know Young modulus? Strain and what? Stress. Good. Stress. Now, what is the formula for stress? What's the formula for stress? I thought work done is mass times gravity. Work done for elasticity Work done for elasticity is not okay. This is work done for elasticity. We are talking about elasticity. We are not talking about mass or something. Why are you on? It's not just one thing, please. Work done can be anything. Can be, in fact, work done for capacitor is half QV or half CV squared. It's not the same thing. Okay. This is work done for extension. It's not about force times gravity. Please take note of that. So there's something called the tensile stress, which is the force over area. That means they can tell you that this tensile stress has the same unit as pressure, because pressure is also force over area. This is just by the way. While strain, tensile strain, is extension over length. Extension over length. Okay. Now, if I now put, since we know that Young modulus, they used to ask this question, is tensile stress over tensile strain, then we say force over area, which is the stress. This is divided by extension over length, right? So from here you can see that I can make it make sense and say F over area. If I want to change this to times, extension length will come up over E. So that's why they say Young modulus is force times length, area times extension. So that's why they say Young modulus, but there's something I want to let you know. Young modulus is what? Force times length, area times extension. Now, if you are very smart, I want to be screenshotting now. If you are very smart, you will see that this looks like Newton, unit of force, area, meter squared, unit of length, of course, is meter, unit of extension is also meter. This is a Jamb question. That means this can cancel this. Eventually, the unit of Young modulus, what is the meaning of old modulus, sir? The unit of Young modulus is what? Newton per meter squared. Now, what am I trying to say? Young modulus has the same unit as what? As tensile stress. Tensile stress. It also has the same unit as what? As pressure. In case of exam, they can ask you, because the actual strain, which is extension over length, is meter per meter, which we cancel out. So this is the easiest topic, is what you don't understand at all. You will come and watch the video. I'm sorry. Thank you. Young modulus is stress equals to, is the same thing as stress, is the same thing as pressure. You just joined. You can't you don't understand. Okoye, what are you saying? Hey, you come and watch it again. Oh. Wow, this is the easiest topic in this topic that we are doing. Oh. This is the easiest topic. Oh. I don't know what you don't understand here. Oh. Now I even use, hey God, that even started work from this, that when you extend this and you apply force, right? The Young modulus. Okay. Please, anytime you say you don't understand something, be specific that this is what I don't understand, not you don't understand. It's easy. I just said Young modulus has a formula, and I just made sure that the formula is what? Stress over strain. Simple. What is stress itself? Stress has a formula, force over area. Strain has a formula, extension over length. That's all. So what if I just, it's easy now. Force over area divided by extension over length. Maybe it's just mathematics. Force over area times length over extension. That is Young modulus. And I asked you that what is the unit? unit of Young modulus, because I know that force is Newton, area is meter squared, length, the unit is meter, the unit of extension is meter. Okay, this one we cancel this. Then the unit of Young modulus is what? Newton per meter squared. That's all. I did not say too much. Are you good now? You don't still get it after writing it again, Abi? Okay. You come and watch it again. You can't join halfway and say you don't understand stuff, okay? You come and watch it again. Do you get it? What is the unit of strain? Good girl. What you tell me? Who has that question? Adeleke. When strain is extension over length and the unit of extension is meter, the unit of length is meter, what will be the unit of strain? Oh yeah, tell me. No units now, just that's simple. Because it will be meter, cancel meter. There's no unit. We said meter squared. How will extension over length be meter squared? Done. Why will extension over length be meter squared? Oh, I want to know. Strain is extension over length. Are you multiplying? How will extension over length be meter squared? How? Just tell me. There's no unit. This is meter. This is also meter. Cancel. No unit. Strain has no unit. In fact, because strain has no unit, that is why the unit of Young modulus is the unit of stress. Because this one has no unit. That's why the unit of Young modulus is the unit of stress. Because it has no unit. It's dimensionless. Okay, so that is that. Let's leave that. We are done with that. So let's go to electricity. Electricity. Please, what you should know there, I've told you the unit of stress, the unit of strain, Young modulus, no, what's it called? Force equals to KE, no work done, half FE or half KE squared. And then know the graph. Elasticity. You can go to your past question and do that, okay? Electricity. Electricity. Now, when there is a flow of current, right? When there is a flow of current, okay? Now, we tend to talk about electricity because it's the rate of flow. Yes, that's all. It's a very simple topic now. It's the rate of flow of electric current. It's the rate of flow of electric current, okay? It's the rate of flow of electric current. It's a very easy topic. Elasticity is easy. It's the rate of flow of electric current. That means if we have conductors, okay? If you have conductors and there is current passing through it, current passing through that conductor, okay? You understand? That means you realize that one of the is not charges, so it's current that deals with charges. I don't like solving past. Do you want me to be solving questions with 2 hours class? You want me to be solving questions in 2 hours class? If it's question approach that you want, I can do that. I will not teach you how to, and I'll be solving question. I'll be telling you the answer. No, it's not that. If that was what you want, no problem. I will just find questions and I will solve it, and I will leave. Everybody will enjoy that way. Current passing through it, okay? Now, so there's no, see, let me tell you something. You guys don't understand something. If you ask me to solve question, what is the question all about? I can form question like this and I will solve it. What will I do? But that's what you guys don't understand. You think I will just give you force, give you area, give you length, give you extension, calculate Young modulus. Won't you be able to solve that? You will be able to solve it now. I will just give you force. Force is 50 Newton. Area is 20 meter per second. Area is 20 meters squared. Length is 2 meters. Extension is 1 meter. Calculate the Young modulus. You will get it. Force, where is the first ohm? You guys will get it, but you don't understand. Understanding concept is the major thing that makes you good in physics. But all of you is finding one question, and if I give you calculate work done, I give you force, I give you extension, won't you get work done? So what are you trying to look for here? If I give you force constant, when I give you extension, calculate work done, what do you want me to just be using my time to 20 minutes to solve something that you can impute? That is your job. Your job is to go to your past questions, to check questions. That's your job. Okay? That's your job. Yeah, I'm here to teach you concepts, to teach you how to understand it. Okay, current passing through it, Abby. Now, you must know that when we talk about as I was saying, so that means one of the effects, and you guys are saying to solve questions. This is what I now do. I do a 40 question series where I bring 40 past questions. I've done 2 chemistry like this, which means I've done 80 past questions in chemistry. I did physics already, 40 questions in physics. That is now where I now solve question series. It's a past question series that I solve questions. So that is where you go and consume questions. I would have just let this guy teach you because I'm even tired. I just want to make sure that you guys don't miss some things. So now, exactly, do you get? Exactly. That's what I'm doing. I'm doing a 40 question series for you guys. I've done 80 questions in chemistry. Have you watched? Ask Juliet, have you watched it? No. But you want me to be using these 2 hours to be solving questions when I'm doing a 40 question series for you guys? I've done physics 40, I've done chemistry 80. I'm working on biology, but you are not watching those ones. It's here that you want me to be solving questions. Okay, what am I trying to say? So, as I was saying, now you have to understand that. So, what's it called? You have to understand that when we have this current passing through these conductors, it can produce what we call heating effect. It can produce what we call what? Heating effect. Heating effect. It can produce what we call what? Heating effect. That's why when you see that something that is, that has current that is passing through it, and you touch it like this, it will be heating up. Yes, absolutely. Metals are good conductors. Definitely, they have electrons. That one is a no-brainer. It will produce what we call what? Heating effect. All right. Heating effect. Now, what I want you to know that here is that there is a particular man, which is the Ohm's law. Ohm's law, abi Ohm's, which says that what the provided that such material is a conductor, provided the material is a conductor. What do I mean by conductor? It allowed for the passage of electricity. The potential difference, which is V, potential difference, what can produce materials that electron current is passing through. Wait, don't you guys have electric iron at home? Don't you guys have charger at home? Don't you guys have stuff that electricity passes at home? Once you touch it, what happens? Won't it be heat up? So one of the effect of current is that there's heating effect. Your iron is what makes that iron be hot like that is because of the current that is being passed. So that's what they call heating effect. So potential difference is directly proportional to the current that is passed, okay? Exactly. That was why we were locked out in physics yesterday class, because of heating effect. My phone was saying temperature too high because I was charging it as we were going live. So it will be hot. In fact, now it's hot too because of heating effect. That's just it. Now, what do you see from here? So what you see from here is that V is equals to what? IR, right? V equals to IR. Now, what do I use something to explain this thing. If I can still remember, yes, I use it. VIR. I use a chart, and I use a chart for two things. For power, look at the way I draw it. Draw a T, then PIV. VIR, VAR, and PIV. So what do I mean? For V, if I need V, just cancel it. Hold V like this. What is left? I times R. Then, if I need P, I need this power. P equals to what? I times V. That's all you need actually. I just want to, like, you can find R, you can find, but if you know this one, you can always manipulate it. If I need I, I'll just say I equals to what? V over R. But if you want to come here, because I need I, I'll just cancel this. It is V over R. If I need I, it is P over, can you see it is over that is here, over V. If I need V, it is P over I. If I need P, it is I times V. If I need V, it is I times R. If I need R, it is V over I. If I need I, it is V over R. All those ones are just by the way anyways. So don't forget that here, if I equals to V over R, I can replace the I here. So it will now be P equals to, replace I with V over R, V over R times V. So that's how you see that power equals to what? V squared over R. So I can always change it anyhow. Same thing, if I want to make sure that I can say, since V equals to IR, just like it's here, since V equals to IR, I can also say, let me replace V with IR. That's how you see that power equals to I times V. But V is what? IR. IR. So that's how you see some textbook power equals to what? I times I squared, then R. Okay? So that is that. So, what are this is what they call resistance. I should come again with this thing. Well, don't worry, just know V equals to IR, P equals to IV. That's all, don't worry. Then I is current. Then V is what? Is voltage. Now, don't forget, this is voltage. That is the quantity. The unit is volt. Don't miss that. Volt is the unit. Current, the unit is ampere. While resistance, the unit is what? Is ohms. If you look at the word resistance, is an English word, which means to resist, is an opposition. The word resistance means to resist, is an opposition, okay? That is why people don't know. So resistance is an opposition offered by a resistor. Resistance is an opposition offered by a resistor, okay? Now we will now go to connections. These are just basic stuff that you should know. Now go to connections. Now this resistor you are seeing, resistors can be connected both in series and parallel. So if you connect resistors in series, just like this, look at what series means, like series arrangement. So R1, R2, R3. So now if you connect this resistor in series, the current that, please, this is the major thing, the current that is being passed to R1 will be the same that is going to be passed to R2. Will also be the same that will pass to R3. Yes, very good. So there will be equal for series connection. So there are some questions you don't have to solve. The current is the same. You don't have to solve it. You will see what I will do now. Let's say, but don't forget that effective resistor, see, as simple as this question is, they ask it in Jamb almost every year. So R total is the summation of the R1, R2, and R3. Yes, so the current is the same, but different voltage. Let me just add it. Different voltage, okay? You must, in fact, this is the statement you need to know to solve almost, see, if you know this statement, you can solve half of the questions in electricity. That is that. Now know this. Now, if I give you a question like this, look at it, 3 ohms. Where is Juliet, the question girl? 4 ohms. And I give you that the I total is 2 ampere. I don't understand this resistor. Wow. Hey, God. You don't understand what I did now. Chico Dilly, Abi, Juliet. You don't understand this one. Wow. Okay. I have to change a lot of things. Okay. Okay, look at this stuff. This is wire. It connects resistor. Resistor is a device, it's a device, okay? We have one resistor. Let me see where we have another resistor. We have another resistor. If you don't know this one, there's problem. Go. But let's continue. Now look at this. This is a series connection. They are aligned together. It's a series connection. If I pass a current through this conductor, if I pass 20 ampere of current, 20 ampere will follow this guy because they are in series. 20 ampere will come and meet this guy. 20 ampere will come and meet this guy. That's what they mean by series connection. That means their current is the same, but their voltage will be different. So if this one is, even though if this one, some of you are even, what are you writing? 20 volts. Who is? I didn't ask you for voltage now. So that is what they mean. So this wire, this thing you are seeing in between, they are the wire, right? This is resistor, this resistor, this resistor. So now, the current that is passing through, that the total current, which is 2 ampere. So we used to write that I total is also the current that will pass through this guy, I2 and I3. So we used to use equal to I1, equal to I2, equal to what? I3. So if I ask you what is the current of 2 ohms resistor, what will you say? The answer is what? The answer is 2 ampere. If I ask you what is the current of this 2 ohm resistor, it's also 2. What's the current of the 4 ohm? It's also 2. Right? Because they are in series. This is what they call series connection. One line. Serially, not parallel. I hope you understand now. So now, but the total resistance RT, look at it, is the summation of each resistor. 3 plus 2 plus 4, which is what? 3 plus 2, that's 7. 7 plus 4, that's what? 11 ohms. That's the total effective resistance. What do you need? How do you need that for? What do you need that for? Whose brush? Is that what you see? How will you understand? Is that what you need to do this stuff? What do you need the brush for? You don't focus on the right thing. Do you get? Is the brush or the syllabus? That's the question. You don't focus on the right thing. Oh, sorry. 5, sorry. 9 ohms. Thank you, Jerry. 9 ohms. Okay, so now look at this. If this is 9 ohms, right, you just realize that I can get V, because I already know that this is the total ampere current and this is the total resistance. So I can say V equals to what? IR, right? So I already got ampere to be 2 ampere and I got resistance to be 9. So voltage is what? Is 2 times 9. So that's why it is 18 volts. Now if I want to ask you a question, this 18 volts is the V total, right? Is the V total. That means it's the total voltage that will pass through everything. So 18 volts, right? 18 volts. That means that 18 volts is not the only volt that will pass through everything, because we already said that the voltage is different. That means that V total, that 18 volts you are seeing here, V total is actually V1, right? V1, like the voltage that will pass through this, plus V2, that is the voltage that will pass through this, plus V3, because plus the voltage that will pass through 3. Because for series connection, their voltage is not the same thing. Like their voltage differs. So the total voltage is the summation of each voltage. I can prove this. I can prove this stuff to you. I can prove this stuff to you. Let me prove it to you. You know, that means the total, when you add V1, V2, V3, the summation must give you 18 volt, Abi. Now let's prove it to you. Let me prove it to you. Let me prove it to you. Look, let's come here. Oh yeah, let me prove it to you. What is the current that will pass through this guy? Look at them. What is the current that will pass through this V1 here? What is the current that will pass through it? I already taught you, but what is the current? Because they are in series. I already said this statement. What is the current? Answer my question. What is the current that will pass through this? 2 ampere. Good. So if I want to get the voltage of this guy alone, if I want to get the voltage of this guy, it will be what? V1 equals to 3 ohms times 2, which is what? 6 volts. Abi now, that means the voltage that will pass here is 6 volts, because the current is 2 ampere times 3 is 6 volts. Now let me go here. What is the current that will pass through this place? What is the current that will pass through this? What is the current? What is the current? 2 ampere. Now what is the voltage? Voltage is what? 2 times 2. We saying 4 again. Hey, I didn't ask you. Question is easy. What is the current? 2. The voltage is now 2 times 2. So V2 is 2 times 2, which is what? 4 volts. Now V3. V3, what is the current that will pass through this side? What is the current? What is the current that will pass through this side? 2 ampere, because they are in series. So because 2 ampere will pass through this side, that's what? 2 times what? 2 times 4. I don't know what you are answering. What is the current is what I asked you. Don't answer the question I did not ask you, please. What is the current? Is a simple question. 2. The voltage is what? 2 times 4. So 2 times 4, 8 volts. Yeah, let's go. Let's add all these guys together. V total is V1 plus V2 plus V3. 6 plus 4 plus 8. What is the answer? What is the answer of this guy? Is it not 18 volts? Is it not 18 volts? Is it not the same thing as this? Understanding no matter. Some things you don't solve it if you understand it. You don't need to solve it. 18 volts. So you see that I prove it that you don't need. So if you ask me now, I should be giving you a question on this, and you already saw this. I don't know what you just waste the time that we're supposed to use to do concepts to be solving questions. If I want to do question, I will not teach you. How did you get 4? From where? 4 from where? Some of you. You don't can't you see 4 here? Maybe it's IR. V equals to IR. V equals to IR. 4 is the resistor times R times I, which is 2. So 4 times 2, 8. Yes. No, it's not 2 volts. It's 2. I don't even know what you're saying. What? So yes, it's potential difference. Yes, it's potential difference. Okay. Now, there's still a long way to actually go. Now let's talk about parallel. What do we mean by parallel? Look at this guy. Look at this guy. This stuff is the easiest. Look at parallel. You will see something that will happen now. That's the way you guys will understand it. Look at this parallel connection. That means if I have 2 ohms, 3 ohms, and 4 ohms. Now, do you know what it means? Look at it. If I pass through I total, look at it. The I total will be going. That's, I mean, current, total current. It will be going. It will get to this point because there is a junction here. In fact, that's what they call Kirchhoff's first law and Kirchhoff's second law. Kirchhoff's first law is on current. Kirchhoff's second law is on voltage. Kirchhoff's, you might not need it now because it's for Kirchhoff's law. So there's Kirchhoff's first law. That's Kirchhoff's current law. Then there's Kirchhoff's second law, which is K voltage law. You might not need it, but if you want to need it, just know that Kirchhoff's current law is first law. Kirchhoff's voltage law is second law. Okay, just take note of that. Now, what happens is that there is a current cut. Yes, when you get here, that means because this current is not total, is the total. Once it gets there, this total will split. It will go and give its own portion to I1. It will give another portion to I2. It will give another portion to what? I3. Do you know what will happen again? They will keep going. They will keep going. They will converge. They will meet at a point again. That is, I1 will now come here. I2 will now come here. I3 will now come here. Eventually, they will also go as I total. They will go as what? I total. So that is why we used to say that for parallel connection, in fact, that's the way to know parallel connection. It is through this method that you know parallel connection. Like through this current cut. If there's no current cut, it's not parallel. I will give you another example now. You will see. Most of you will bang it if I ask you. So that's why for parallel, current differs. Right? Because just like what you can see, there's a current cut. Then voltage is the same thing. Voltage is same. Now let me ask you a question. Is this a parallel connection or series? Two ohms, 3 ohms, 4 ohms. What's your question? Is this a parallel connection or series? Who can tell me? Good, guys. You guys are good. So look at, in series we did like this. Something like this, right? As what you guys are familiar with series. But what happens here is that we just folded it. This same thing, we folded it like this. That was what we did here. We folded it like this. So it's at the same as, look, this is like what we did. This thing is not different from when you extend it as this. It's not different. It's the same thing. So this is a series connection, not parallel. So if I ask what is the effective resistance for this, effective resistance or R total or effective is just 2 plus 3 plus 4, which is what? Which is 9 ohms. So that's very easy. Don't understand? No. There's something somewhere. If anybody teaches you more than what I taught you like this, that person will be human. The person is not from this earth. Have you left school since? Juliet, have you left school since or what? What's happening? Or you just want to stress me? I don't know. I use my chain. I off my chain. I off my chain to explain. Still same thing. I don't know. I think there's a background issue that we need to address. Can you even message me? I don't even know you. Like I don't know your face. Just please message me after this class. I am sure they know it already. That's okay. If you don't know this thing before, and the way I explain, will you know it? Will you get it? Julia, just send me a message. Just send me a message. I think we need to talk. Okay, sir. Okay, series. Okay, series is not in straight line. Series don't have to always be straight line. It's straight line, but it doesn't have to always be. That's what I'm trying to. So look at this. It's also a straight line. I'm just trying to tell that it doesn't have to always be straight line. This thing that you saw here is the same thing as this. 2, 3, 4. What I just did is that was why I used my chain to explain. Look at it. I now twist it like this. So now I'm trying to say that this thing you are seeing here is the same thing as what you are seeing here. So I don't teach A level. I don't teach A level. So I just said this one is Kirchhoff's current law. This is Kirchhoff's current, which is first law. Then this is Kirchhoff's voltage law. This is O level, A level. That's why I don't want to dwell on it. This, or they call this one loop law. They call it loop law. Yes, it is recorded. It is recorded. You could drum inside. That's why I don't want to dwell on this. Okay. Now let's continue. So after you understood that series don't converge at a point, at any point. So now you have to understand something that there's something called EMF, terminal voltage, and what we call voltage drop. Okay. Now just note, don't disturb yourself. EMF, which is the total EMF, like the total voltage, is actually big V plus small v. That's all you need to know. So big V plus small v. That means big V, EMF, this big V that you are seeing will be big I, then big R. Then this small v, this one is called voltage drop. Then this one will be I plus small r. So now you would have heard something they call external resistance. And there's something called what? Internal resistance. Okay. So from here you can see that E equals to I is common. I into R plus R. Leave how you understand, please. No, it's not electromotive force, not electromagnetic. Electromotive force. Electromotive force. So this is external resistance, internal resistance, and this is E. So you can see a question where they will ask you to calculate anything on EMF and internal resistance. So this is the formula you use. So EMF equals, this one is also in volt. This is ampere, this is ohms, this is what? Ohms. Okay, so you must know this. So does EMF mean yes, electromotive force? Now EMF, electromotive force. EMF, electromotive force. It's not attraction. What are you saying before? Do you get that now? Sir, I is I current. Yes, now ampere. That's what I said. Ampere current. Now I said it here. This is external resistance because it is big R. External. Small r, it is internal resistance. Okay, why this one is the total voltage. So what basically are we still doing? Yes, we'll do it, sure. So this V you are seeing here is the terminal voltage. This small v is the voltage drop. Why this one is the what? Is the EMF. Now, there's something you have to also understand as we go, is what we call what do we call this here? I'm coming. Okay, there's something called potentiometer. Yes, potentiometer. Okay, there's something called what? Potentiometer. You must understand this one if you really want to like score very well, because most people don't know it. And there's something called meter bridge. There's something called meter bridge, potentiometer, meter bridge. Number 2, meter bridge. Okay, then there's something we call what? Wheatstone bridge. How many of you have heard Wheatstone bridge before? How many have heard Wheatstone bridge? Good. So potentiometer, Wheatstone bridge. Good. Okay. So now you would have seen, I don't know if you guys have seen something like this. R1 have you guys seen something like this before? I'm trying to look at the question here, like the way they structure it. Yes, that's Wheatstone bridge. Wheatstone, not who is spelling Wheatstone bridge. Wheatstone, WHEAT. Yes, Wheatstone bridge. So this is what they call Wheatstone bridge. Wheatstone, yes, Wheatstone. Wheatstone bridge. Now I just want to teach you that R1, R2, R3, R4. Anytime you see this, don't calculate, don't do anything, just pick it. R1 over R2 equals to R3 over what? R4. That's what, like this one over this equals to this one over this. So R1 over R2 equals to R3 over R4. Let me find a question. This guy that I love questions so much. Oh yeah. Now that I do this, look at it. Let me give you a question from here. Oh yeah, look at this. Look at this. Look at this. This is Wheatstone bridge. Look at what I said though. This over this equals to this over this. Then I gave you a question in exam. Oh yeah, Juliet, find the from the diagram below. Find the value of R4. This is R4. Oh yeah, can't you solve this with what I told you? That R1 4 over R2 2 equals to 3 over R4. So what is R here? So R4 equals to what? 6 over 4. Abi, then you put the unit. Since they are using micro, you just put it. This is the answer. This is a worked example. So you want me to be coming here to be talking, giving you a question like this so that we can waste time? That's the problem. That's what I'm trying to tell you. Like, this is the question, this is the stuff. Do you get? I'm just trying to tell you that you don't need to stress yourself if you understand the whole concept. So the other one, I just want to show you that so that you understand that you don't need to waste your time. So just note that it is like this over this, like, or sometimes if you don't want to do like that, you can do it in another way. So do you have other ones like Jamb questions? I don't want, then you can just do it like this. I solve other ones on the 40 series, don't worry. R1 times this. That's, you guys think Jamb is hard, but until you understand that it is not hard. So you can just do, or don't worry, don't let me stress, just put anywhere you see R1, just put R1 over R2 equals to R3. You see, this is the problem we are talking about. Omotola Adeyemi, she's asking what is the answer in that question. Do you need the answer when I've taught you how to do it? I don't care the answer. It's that you know what to do. The answer is 1.5 if that's what you want. You don't need the answer now. What do you want to use the answer? I'm not your love. No, I'm not your love at all. Please, I'm not. You stress me so much. Just message me. That's by the way. I want to talk to you because all the things you don't understand. We need to talk. So okay, potentiometer. For potentiometer, you have to understand that yes, we are doing that. For potentiometer, you have to understand that what you just need to know that it is EMF1 over EMF2 equals to length 1 over length 2. What do I mean? They will give you a length such that there's an EMF. Let's say this is from here to here. Let's say from here to here is L1. I'm just giving you an instance. Then from here to here is L2. And from here to here has an EMF 1. Then from here to here has an EMF 2. So we didn't ask last year. I don't understand anything about physics. So from here you will see that you just pick, we relate it. It's directly proportional. That is, EMF is directly proportional to what? To length. So when I do EMF equals to KL, so you now say, oh, E equals to E, like divide both sides by L equals to K. So from here you say E1 over L1 equals to E2 over L2. Now if I now collect like times, I will say E1, L2 will come here, like E2 will come here, then L1 will go here, L1 over L2. So that is why I got that this formula you are saying here. That's why I got it. The formula is easy. E1 over E2 equals to L1 over L2 for potentiometer. This is for potentiometer. It's used to measure voltage, EMF, like potential difference. Okay, potentiometer. So take note of that. Now, there's another thing I have to note. Please take note of what I said here. So they will just give you EMF1, EMF2, L1, L2, and calculate L2. Yes, biology is starting in 10 minutes, you see. Okay, what do I need to tell you? Just note this. What's it called? How to galvanometer to ammeter. I have a video on this. I hope you got galvanometer to voltmeter and ammeter. You should have watched this video. But galvanometer to ammeter, you should have watched this video that I explained. Oh, I will send it to you, but you have to note something that you want to convert galvanometer to ammeter. What do you need? Who can tell me what do you need? I think I use gasp. Galvanometer to ammeter. You need a what? A low resistance shunt in parallel. Low resistance shunt in parallel. This is a Jamb question. Oh. Shunt, low resistance. So the opposite will be for voltmeter. Galvanometer to this ammeter, voltmeter. So you need a high, since this one will turn to high. And I told you that for it to be high, it will not be a shunt. It will be a what? A multiplier. It will be a multiplier. Then since this one is connected in parallel, and for you to multiply, you must be connected in series. So high multiplier in series for galvanometer. So you must know gasp, so that once you know for ammeter, you will definitely know for what? Voltmeter. So that is that on this. You need to know this one. Anything balu. So that is that on that. Let me see what I've not touched. So I'll just move on to simple harmonic motion. Okay. Okay, now please, you must know capacitor. Okay, no, first of oh, where is it? I think capacitor. We've not talked about capacitor. Let me just move to simple and transformer. Yes, simple harmonic motion. Yes. We just have to like push through these things so that you guys will not. Now you must know capacitor and capacitance. Okay. Capacitor and what? Capacitance. Now, capacitor is used to store charges. Yes, capacitor and capacitor. Capacitor is used to store charges. Capacitor is a device used to store charges. Okay, it's used to what? To store charges. Now, you must understand something about the dependence. What capacitor depends on. But what is capacitance itself? Capacitance is defined as the amount of charges stored in between two plates of a potential difference V existing across the plate. Now look at what I'm trying to explain. Like, you can have two plates, like, right? Look at something. I don't know how to draw this. So that you can have like another plate below. Let me just draw it. Like, I just want to show you that we can have two plates. So this plate 1, this plate 2, right? Now that means in between these plates there's something called dielectric what? Who can tell me what? There's a dielectric material here. In between this space, there's a dielectric material. So that means it's a space between, like, you have two plates. Let me show you. This one plate, this another plate. AC circuit. That is AC circuit is tomorrow. Don't worry. You can see there's a space in between this guy. So the amount of charges, right? The amount of charges that is stored. The amount of charge that is stored in between these two plates that you are seeing. Because we said capacitor is used to store what? Charges. So there are two plates that form this is one plate, another plate. So in between these two plates, right? Charges is being stored. So the amount of charges that is stored in between two plates for a potential difference V existing between the plates is what we call capacitance. So capacitance is the amount of charge that is stored in between two plates. Okay, now this is not the major thing. Is that you must know that capacitance is directly proportional to area and inversely proportional to D. See, if you don't know anything today, you must know this. CAD, like C directly proportional to A all over D. This is distance. Yes, dielectric material and insulator. Exactly. You guys should listen to the ones. So A over D, Abi. Inductor and capacitor, that's AC circuits now. That's AC circuits. So from here, what do you observe? That means I can say that capacitance is equals to a constant. This is the dielectric material, right? Dielectric material A over what? Over D. Because we said it's directly proportional to area over D. So when this guy change, it will be C equals to this dielectric material or dielectric constant over D. Do you get that? So that this stuff has a value actually. It has a value. This dielectric material, this dielectric value, there's a value for it. So most of the time they will give it in the exam. They will give it, you don't need to cram it. You don't need to cram it. Okay. Where E is the constant? Yes. Yes, but they will give you in the exam. But you must just know that it is A over D. That means capacitance depends on what? Who can tell me what capacitance depends on? Tell me. Capacitance depends on what? Just like you can see it. It depends on what? You can tell me what it depends on now. I don't understand this part. It's formula now. You don't just know that capacitance is directly proportional to the area of this plate and the distance between them. Capacitor is directly proportional to area over D. I just said a statement. So it depends on one, dielectric value of the material. I'm just trying to, this is easy now. Area of the material. You can come and watch it again anyway. Distance of the material. So that's what capacitance depends on. C, it depends on A over D and E. Area, distance between the plate and what? Dielectric material of the plate. It depends on dielectric material of the material. Depends on area, and it's not only area and distance. I'm mentioning something. You guys are still mentioning area and distance alone. It depends on dielectric material, area, and distance. So I know what I'm trying to explain now. So take note of that. So, but then you have to know what capacitance itself. This is based on the area and distance. You must know that capacitance itself is actually the charge per unit volt. So capacitance, dielectric material, yes, area and D is the charge per unit volt, right? That means I can say this charge Q is actually equals to what? CV. You must never forget this. This is charge, this is capacitance, and this is what? This is voltage. So this Q over V. So when you cross multiply, CV equals to what? Equals to Q. Now, you must know something, that the math teacher is here. Oh God. Let me just stop at work done. The work done for please, I'll stop at two things. The work done for capacitance is what? Who can tell me? Have what? Who can tell me the work done for capacitance? Who can tell me the work done? Who can tell me the work done? Work done, yes, is half. I will start is half QV, right? That's where you start from. You guys are good now, but you must never forget that Q itself is CV. Julia, don't forget to message me. I want to talk to you. Q is what? CV. So if Q is CV, that means work done equals to what? Half. Now Q is CV, so I'll just replace it with CV times V. So that's where you guys got your half CV squared. So you must know this one, because they might not give you CV and they'll give you Q. So how will you do it? So you must start from here. Half equals to QV. Then because you know that Q is what? CV, you just replace it. It will now be CV squared. So that's where you guys got your half CV squared. Okay. Now, this is not where I'm going. There's something I want to teach you that you must know. And that will be, so half QV first. This is one. Then Q is CV. Then replace Q with CV, it means half CV squared. This is formula 2. Now, this is the last part, then we'll go. You must know that when capacitors, this one is the opposite of, we can use IT to find Q bar. IT to find Q as well. This is not that charge, like it's not that way. You can, they will give you Q directly. They will give you the charge. Okay? They'll give you the charge. And don't forget, before I move on, that the unit of capacitance is what? It can be what? It can be microfarad. The unit of capacitance, it can be what? Microfarad. So capacitance of a capacitance is what? Microfarad, okay? Take note of that. But I said it's the opposite of what? Resistor. Now, never forget that if capacitors are connected in series, you know, for resistor, we are doing plus. This one will be 1 over C total equals to 1 over C1 plus 1 over C2 plus 1 over C3, like till infinity. So if they are connected in parallel, it will not look like series. That's when C total will now be C1 plus C2 up to Cn. Do you get? So what I'm trying to say is that for parallel for capacitor is for series for what? For resistor. Like R total is R1 plus R2 up to R3 depending. But you know, this series for capacitor is the what? Is the parallel for what? For resistor. So if capacitor store charges, what does resistor? Resistor oppose charges now. Shiva, I told you, it's an opposition to the flow of current. I told you now. That's why they are opposites. This one store charges, this one oppose charges. And I even use the word resist. Resist means oppose. Do you get? So please take note of that. Okay, let's just solve one question because of Juliet, so that she will not swear for me. Juliet, see this question. Juliet, yeah, see this question before we go. Calculate the work done on a capacitor of capacitance this. Work done. Calculate the work done of a capacitor of a capacitance what? They say the capacitance is what? 200 microfarad. When the potential difference V is what? 1000 volts. Now, don't forget, there is C, there is V. Now, we already said that work done is what? Half CV squared. We don't have issues because we can say work done is what? Half QV2. But because they just gave me capacitance and they gave me V, they did not give me charge. So I don't have to use this. I will just use this. Okay? So that's why I will now say half CV squared. So what is C? What is C? C is what? 200 microfarad. But don't forget that this micro, I already taught you, micro is what? 10 raised by what? Minus 6. I already taught you, micro is what? 10 raised by minus 6. So that's why this will be what? Half times C, which is 200. Micro, you must convert micro to, like, take it away. 10 raised by minus 6 times V squared. 10 raised by 3. This is 10 raised by 3 raised to power 2. Like V squared, okay? Squared. So, exactly. So, if you do this, 1 over 2 times. Now, if you know math very well, look at what I will do. 10 raised by minus 6. Who can tell me what is this value? What is this value? Who can tell me? If I have 10 raised by 3 raised by 2, where are the math students? It is 3 times 2. That is what it means. 3 times 2, which is what? 10 raised by what? 6. And because I don't need to calculate again. Hey, we say 9. 20 squared into squared. It means 20 into 2 times 2. Am I not shikini you? If I say A squared into Y, it means A into 2Y. That's what it means. A Y raised to power squared. It means A 2 times Y. That's what it means. Oh, don't go and miss this thing. I'm saying 9. I didn't say 3 raised to power 2 like this. I said 10 raised power 3 into 2. It means multiplication. That is what it means. Don't go and miss this thing. Mathematics. Hey. So, but since they are of the same base, law of indices, can I add them together? Since they are of the same base, can I add them together? Yes. So they can cancel out because it will be 10 raised power minus 6 plus 6. And 10 raised power minus 6 plus 6 is what? 10 raised power 0. And anything raised power 0 except 0 raised power 0 is what? 1. So 1 times 200 times 1 over 2. So that's why this becomes this becomes work done equals to 1 over 2 times 200. So 2 here, we cancel this. Then I have what? 100 what? What is the unit of work done? What's the unit of work done? Regardless of where you are solving it. It is what? What's the unit? That's the last thing. What's the unit? Joules. Regardless of where you are solving it. Joules, you see. So what are the formulas we've said? If they are in series, 1 over C1, C total equals to 1 over C1 plus 1 over C2 up to 1 over Cn. Please note, don't know how to calculate this thing. It is C total that they ask you to calculate. Okay, let me give you a question. Let's say we have 1 over C total and 1 over 2 microfarad plus 1 over 3 microfarad plus 1 over 4 microfarad. Who can solve this? Please don't go and make mistake of just solving this and say that's the answer. This is what you do. 1 over C total. What is the LCM? Don't disturb yourself. If you want to get it, just multiply everything together. 2 times 3 times 4. So how many 2 can you see in this? 2 will cancel 2. It remains 12. 12 times this, 12. Plus, how many 3 can you see? 3 will cancel this. It remains 8 times 1. How many 4 can you see? 4 will cancel 4. It remains 6. It's because I don't want to use LCM. I want to use, the LCM here will be 12. But I just want to use it for people that don't know LCM. Just multiply all this and put it down and do this. Now, what am I trying to say? There's something I'm trying to bring out from this thing. Is that eventually 1 over C total equals to 12 plus 8 is what? 20. 26 over 2 times 3. 2 times 3 is what? 6. 6 times 4 is what? 24. Now, what am I trying to say? This is 1 over C total. But C total itself that they asked you to look for is actually 24. Like, don't let me move on. Like, just cross multiply. So you say C total times 26 equals to 24, right? So C total will be 24 divided by 26. So C total is this. Like, you can do it anyhow you want. 24 divided by 26 microfarad. That's the answer. So what I'm trying to say is C total is C total, not 1 over C total. So find a way to make sure that you are looking for C total. So you can now say this is what? 12 over 13 microfarad. So that is that. I hope I've been able to make justice to this. So I've done capacitor, capacitance like that. In fact, I'm done with electricity like that. I don't think there's anything I've not touched. So guys, that is it. It's not hard. Just pay attention. That's why I don't want to be like, all these things are very easy stuff, okay? So so you guys can go for your biology now. So we are left with simple harmonic. Though there's a video that simple harmonic motion and second law. He has made a video on it. Like, I just want to use this thing to like explain to you so I don't waste the whole time. I don't like when you waste time because some people exam is very close. Please guys, don't forget all I've said. Oh, please don't forget. C equals to what? This A over D. Don't forget all this. Work done of this is half CV squared. Don't forget all this that I'm saying is. So yes, it's not more grease, it's more power to your elbow. That's the English. More power to your elbow, not more grease. So you see that you got the answer. So guys, so don't forget all these things I've said. So we are done with electricity and what is it called? What's this topic? Elasticity too. Elasticity. So I don't know. Those are like, I think those are the 2 topics we did. So there will be recording definitely. Yeah, Naoma, you're welcome. Thank you. Sorry, I don't understand how you got the LC. I did not get LCM. That's what I'm saying now. You see what I'm saying? I did not get LCM. Just any that you want to get LCM, just multiply the denominator and put it down. How many 2 can you see this? 2 will cancel 2. It remains 3 times 4. That's 12. Put it here. Like 12 times 1. How many 3 can you see this? Cancel this 3. 2 times 4, 8. 8 times 1, 8. How many 4 can you see this? Cancel it. Then 2 times 3, 6. 6 times 1. That's all. If I want to get the LCM, actually, the LCM of this is actually what? Is 12. That is, what can 2 go in without remainder? What can 3 go in without remainder? What can 4 go in without remainder? That is LCM. Yes, my way of solving is different. You have started. It does not matter. Whatever you want to do, you can do it. So I can use 12. 12 in 2 in 12, 6. There will not be remainder. 3 in 12, 4. There will not be remainder. 4 in 12, 3. There will not be remainder. So this is what I should have used. But because I don't want to waste time, I don't want to. Most of people say we don't understand how I got this. Just multiply. Anytime they give you something like this, you can just multiply everything together and find each of them. You get it. So that's why I just use this method. You're good. Thank you. Is AC cycle. That is AC cycle. This is what we need under current. That one is AC circuit. Where we're talking about SL equals to 2 pi FL. SC equals to 2 pi 1 over 2 pi FC. This one is under AC circuit. Tomorrow, I will send you the link. Tomorrow we'll talk about this. Isaac is coming to teach you guys tomorrow. I will send you the link, guys. I tested you. No problem. I will send you the link. Juliet, I want you to text me too. Thank you. So I don't know, tonight, I don't know if if I'll be able to teach you guys chemistry, hopefully. But I'll find a way to make sure like I teach it or something. But I just pray for strength. I just have to teach you guys. I don't want you to waste time. That was why I had to come. So bye. Go to your maths and your English class. See you. Juliet, message me, Juliet. Onasonye, message me, please. I'm expecting your message. I want to talk to you. Can you hear me, Juliet? All right, guys. So yeah, go to your class. Go to your class. You can go now. You can go to your class. So you can go to your class. XL is inductive reactance. Don't worry, you will know this one in AC. Why this one is capacitive reactance? You will know it in AC circuit. It's in AC circuit. The unit is ohms. The unit of these guys is ohms. You will know it in AC circuit. Don't worry. I just want to let you know that it's different. The unit